All right, so if you have a positive exponent, you guys, that means that your number is very, very, very big, okay? However, if you have an exponent that is negative, that means that represents a very, very, very small number. So remember that right here. If your exponent is positive, it means you're going to be moving your decimal to the right because you're creating a large number. If you have a negative exponent, you're going to be moving your decimal to the left because you're going to create a small number. So this number right here has to be between the numbers of 1 through 9. The first digit can only be a 1, 2, 3, 4, 5, 6, 7, 8, or 9. And then you're almost always going to have a decimal. And like I said, you're going to be showing that it's being multiplied by a power of 10. All right, so look at these directions right here. It says we're going to start with 1.5. We're going to look at the exponent. It's a positive 4. And that positive 4 tells us we're going to move our decimal place to the right 4 spaces. We're going to move our decimal place to the right 4 places. All right, so that's what we did. We started at 1.5. Since our exponent is a 4, we move our decimal 1, 2, 3, 4 spaces, put the decimal at the very end, and then the easiest way to read a number is if you'll add commas, okay? So this number actually represents the digit 15,000. All right, the next one, we're going to start with 5.8. Since our exponent is negative, that means we're going to move our decimal to the left 4 spaces. So we're starting at the end of at 5, and we're going to go to the left 1, 2, 3, 4 spaces, and that's where our decimal goes. So this little bitty number, it's not a negative number and it's not 0, but it's very, very, very small. All right, so we're going to practice changing numbers from, let me erase all this stuff, from exponential form to standard form. All right, so let's look at this one here. It says, right here, we have 3.57 times 10 to the 6th. So positive 6 means we're going to make this number bigger because it's positive. And the 6 tells us how many spaces we're moving our decimal. Got it? So we start out 3.57. So we're going to move it to the right 1, 2 spaces. So it's right here, 3, 4, 5, 6. And so that's why we end up with 4 zeros. And then we start from the back and we come up every 3 digits, we add a comma just so it's easy to read. So this number in scientific notation represents the number 3,570,000. All right, this one down here, first of all, I see a negative exponent, which means this number is going to get even smaller. My exponent tells me how many times I'm moving my decimal. So we're going to move our decimal 7 times to the left. So it was here, but we're moving it 1, 2, 3, 4, 5, 6, 7. So this number right here actually represents this very small number that I actually don't even know how to read correctly. I don't know. What would that be? Tenths, hundredths, thousandths, 10,000ths, 100,000ths, 100,000ths, millionths, 10 millionths, 100, no. I guess it's in the billionths position. Maybe, maybe not. All right. Do you understand? Does everyone understand? Good. Couple of nods, 1 thumbs up. Okay, I'll take it. Can I move on? Okay. So it says numbers greater than 1 will have a positive exponent. Think large numbers. Numbers less than 1 will have a negative number. Think really small numbers. So if we have a number in standard form, So we're going to convert these to scientific notation. So originally this was a comma, right? So we had 3,250,000,000. So this is a huge number, right? This is a huge number, which means our exponent is going to be positive. So you have to have your first digit, the only digit in front of that decimal can only be a single number. So that means you are taking this decimal that's way here at the end, way far here at the end, and you're going to move it all the way up to where it is between the 3 and the 2, because there can only be a single digit in front of the decimal. And then however many places you move it, that's what your exponent is. So it was at the end, and we moved it up 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's where the exponent of 9 comes from. So we took this great big number and we wrote it in scientific notation. The 9 comes from how many places you move your decimal, and there can only be a single digit sitting in front of the decimal. And then when you get to only zeros, you drop all those other zeros in the answer. All right, so now we're going to look at this very, very small number. Small numbers means negative exponents. So I'm moving my decimal from here to behind the 4. So how many places does that mean we moved it? We moved it 1, 2, 3, 4, 5, 6, 7. And since it's a tiny number, our exponent is negative, and we can only have a single number in front of the decimal. So 4 is the same thing as 4.0. We have a single digit in front of the decimal. All right, I see a couple people taking notes, so I don't want to rush. All righty, I'm moving on. All right, so here we have, see, it's hard to read big numbers without the commas, so I always try to add the commas. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So we have 1,270,000,000. I only want one single digit in front of the decimal, which means I'm moving my decimal from here all the way up to behind the 1. So it's a big number, first of all. That means I have a positive exponent. I'm going to write all non-zero numbers. So do you see what I mean by that? We're going to write all non-zero numbers. So 127, I can only have a single digit in front of the decimal, which means it has to go behind the 1. And then the last thing I do is count how many spaces I had to move that decimal from the end to behind the 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's where the 9 came from. All right, here we have a small number. You have to write all non-zero numbers. Well, the only non-zero numbers are 8, 4. So that's what I write in the front. I can only have a single digit in front of the decimal, which means 8.4. So if I'm moving my decimal from here to here, you got to count how many spaces that is. 1, 2, 3, 4. So this is a 4. And why is it negative? Why is it a negative 4? Because it's such a small number, right? Is that what you were going to say? Yes, because it's such a small number. Exactly. So getting easier to understand, not too tough, right? Yeah? Okay. Good. All right. Once again, numbers greater than 1 will have a positive exponent. Numbers less than 1, like this is less than 1, is going to have a negative exponent. Don't forget. There we go. There we go. We already did those. All right, so we're going to change numbers that are written in standard form, regular numbers, into scientific notation, okay? Numbers written in scientific notation. The first digit must be 1 or greater, but less than 10. Only one digit in front of the decimal. All right, so I'm going to do the first one with you, and then you guys are going to do the rest of them. Are you ready? All right, you have to write all non-zero numbers. So what are our non-zero numbers? Our non-zero numbers are 724. So we're going to start with writing 724. I can only have a single digit in front of the decimal. So where does my decimal go? Yep. Good, Hayden. Good, Ashlyn. 7.24, right? So far, so good, everybody? All right. You always multiply your number by a power of 10. How do I get my exponent? How do I know what my exponent is?
And how many times how many times you divide it by 10 to make it that answer?
Yes. So first of all, it was sitting at the end and I moved it all the way up here. So how many spaces is that? Text me. Text me. How many times did I have to move to go from here to here? Good, Rylan. Good, Colton. Good, Colin. Good, Ashlyn. Good, Darius.
That was easy.
Yeah. Good, Kyra. Good, Claire.
All you need to do is count by the commas serve as a little, you know that each comma is a 3.
Yeah.
3 numbers. So technically just add the 3 of them together and boom, you get the answer.
Boom. Did y'all hear that? Colin dropped the mic. I like it, Colin. All right. Now I did say all non-zero numbers. However, look at number 2. If there is a non-zero number to the right of a 0, you can't drop it. You see what I'm talking about? I have to go all the way to the 6, even though there is a 0 in there. Since it's surrounded by non-zero numbers, you can't drop it. So we're going to write 8506. When the rest of them are all zeros, you drop them. You drop them. Okay. All right. Where does my decimal go? Hayden knows. Who else knows? Who else knows? Ashlyn knows. Colin knows. Does anyone else know where my decimal goes? Anyone? Colton knows. Kyra, you're so close. There can only be a single digit in front of my decimal, guys. Only one number. That's it. My decimal must go right there. Okay? Behind the 8. You got it, Rylan. All right. And then don't forget, you always multiply by a power of 10. What's my exponent, everybody? Hayden knows. Colin knows. Ashlyn knows. What's my exponent? Uh-oh, it's not a 4. It's not a 4, you guys. How many times did we move it? Where was it, guys? It started out here. We moved it here. How many places is that? 1, 2, 3, 4, 5, 6, 7. 7. Do you understand? All right, everyone send me number 3 in scientific notation, which means you have to put times 10 to a power. Ready, set, go. I love it. Good, Hayden. Good, Ashley. Good, Colin. Colin didn't type it all, but I know what you meant. Ugh.
I clicked the wrong key.
Okay, good. Good, Kyra. Yeah. Kyra, Kira. Why can't my brain work? Kira? Yes, Kira. Good, Colton. Good, Colin. Good, Rylan. All right, this is what I'm seeing over and over and over. I'm seeing 8.4, right, times 10 to the, guys, look at the screen. The decimal was here. We moved it here, right? Let's all count how many spaces that was. 1, 2, 3, 4, 5. It's 5. How many times you move that decimal is your exponent. Do you understand? Okay. Why are all three of these exponents positive? Why? Why are all three of these exponents positive instead of negative?
Because we're going forward, not back.
Yeah. Give it to me even simpler instead of directions. Tell me why. Are these really big numbers or are they really small numbers?
Big.
Yes. If they're big numbers, you want a positive exponent. If you want this to be your bank account balance, use a positive exponent. Got it? Because I definitely would like that much money in my bank account, and I don't have much. I don't have near that. All right. Try these three. Ready, set, go. Shiloh, send me some answers, girlfriend. Send me some answers. Guys, what kind of exponents should we all have? What kind of exponent? Not positive. Negative. All righty. Some of you have got it, and some of you have not listened to anything I've said, obviously. All right, so we are moving our decimal all the way back here. Remember, we have to write the non-zero numbers, but we do include zeros that are between regular numbers, right? So we have to start with these numbers. Where does our decimal go? There can only be a single digit in front of my decimal. And now I'm going to multiply times the power of 10. How many times did we move our decimal? 1, 2, 3, 4, 5 times. Do I put a 5 here? Am I right? I'm so close, aren't I? It's negative. Yes, it's got to be negative because the number's so small. Do you want this to be your bank account balance? Negative. No, of course not. If you don't, use a negative. All right, what about number 2? What are my non-zero numbers? They're 6 and 1. Where must my decimal go? Behind the 6, because we can only have a single digit in front of the decimal, right? Now, we move our decimal from here to here. So we move 1, 2, 3 spaces. What kind of exponent do we need? Do we want to have less than 1 cent in our bank account? No, negatively not. Negatively not. All right, number 3, we're going to start with 5.46. A lot of times, this is what people do year after year. Okay, common mistake. People will do this right. They'll count correctly. 1, 2, 3, and this is what they'll write. Is that scientific notation? No, they forget some of the rules. And I'm like, okay, I know what you meant, but you can't write like that's not right. Times 10 to the negative third. All right, who got them all right? Raise your right hand. Got them all right? Raise your right hand. Raise your right hand. All right. Turn yourself around and pat yourself on the shoulder and say, good job. You're so smart. Oh, it's okay, Ashley. It's okay. All right, guys. Well, let's see what else is coming up. All right, now we're going to do the opposite. Now we're going to go from scientific notation to standard form. So we know, first of all, Positive numbers means they're very, very large, right? We also know that negative numbers are very, very small. So that helps you remember which way you're moving your decimal. You're either making your number bigger by adding zeros or smaller by putting zeros in the front, okay? So for the first one, we're going to start with 8-4. We know we have to move a decimal 4 times and it's positive, which means this number becomes much bigger. So we're going to move it 4 times. So if it was here, we're going to move it 1, 2, 3, 4. And of course, you don't need to do it that slow. I'm just making sure you see what I'm doing. So number 1, the standard form, this scientific notation actually represents 84,000. Do you understand? Okie dokie, you have to do numbers 2, 3, 4, 5, and 6. Ready, set, go. Okay, guys, so just remember a couple of things. You can't have more than 1 decimal in a number. When you add commas, you got to start from the end and count left 3 numbers, add a comma. Start from the end and count to the left 3 numbers and add a comma. One, two, three, four, five, 6. Number 5, I'm sorry, Ashlyn. It's so, yeah, 4 jumps, right? Not 4 zeros, 4 jumps, Rylan. It's hard for me to grade these. They're all coming in at different times and there's zeros everywhere and commas everywhere. We'll go over them. All right, 30 more seconds. Good, Shiloh. That was right. Good, Colton. All right, here we go. Let's check them. Guys, if you're missing these, and I mean, a lot of you are, honestly, a lot of you are, you need to make sure you're writing some notes. You're taking notes, okay? All right, so the first one, where did the 4 come from? It doesn't have anything to do with how many zeros are in the answer, right? It's how many times you move your decimal. So we moved it 4 times. So we went to the right one. In order to move it 3 more times, we had to add 3 zeros, okay? Number 2, we know 3, 2, 1 are our numbers. We have to move our decimal 7 times. So we're going to move it from here. 1, 2, 3, 4, 5, 6, 7. Now look at the screen real quick, guys. When you add those commas, you must put them in the right place. You start from the end and you must count left 3 spaces, 1, 2, 3 for those commas, okay? So you would say this number 32,100,000. Okay, so that is the right answer. If you're not sure where the commas go, leave them off. Don't miss it because you have the commas in the wrong spot. All right, what about the next one? We're going to move our decimal 10 spaces. Well, I know I have these 4 digits at the front. I'm going to move that decimal from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now it's a lot easier for me if you do put the commas in there, but they're not required. They are just requested if you know where they go. Okay. So 10 billion, 60 million. That's my favorite bank account balance. That's what I want right there. Yay, happy teacher. I can't make the rest of the hair. There we go. All right. So no decimals. No decimals in these, guys, because the decimal is literally sitting at the end. And if you have a number, any number like 5, no one writes it like that. They just write 5. Okay. So if you wrote any decimals on 1, 2, and 3, make yourself a note. Okie dokie. What questions do you have? Yep, this is the very first time we're ever doing this, so it's totally
Miss
fine.
Thompson,
Yes.
does it
Go
do the
ahead.
same with negative, like the -4, -5, and -2?
What about it? Say it again.
Does it do the same, like, is it like as number 1, 2, and 3?
Well, what's the difference in a positive exponent and a negative exponent? Tell me.
One of them are bigger.
Yeah, these are huge numbers. These are huge numbers. If it has a negative exponent, that means it's a very small number. Okay? All right. Any questions? Any other questions on the top 3? Okay, so now we have negative exponents. That means these numbers have to be small. All these numbers are going to get smaller, which means, would I be moving to the right to make a number smaller with my decimal? No, I'm going to move it to the left. I'm going to move that decimal to the left 4 spaces. So 1, 2, 3, 4. Now these all have to have decimals. They must have decimals. If you try to write this number without a decimal, it doesn't make any sense. Okay? You can add a 0 in the front of the decimal, it's fine. It doesn't make any difference in the value of this number. But if you don't have, if you write if you type all these digits and you have no decimal right here, this number would not make sense. So the top ones, no decimals. On the bottom, they must have decimals. All right, 4.7. I know I have a 4 and a 7. I'm moving my decimal to the left 5 spaces. So I'll go 1, 2, 3, 4, 5. It's going right there. If you want to add a 0 in the front, that's fine. You don't have to, but if you do, it's totally awesome. It's fine. Okay, no commas in these either. No commas. No commas, must have decimals. And then the last one, we're moving our decimal up 2 spaces. So from here, 1, 2. That's it. There's our answer. All right, how'd you guys do? I mean, I think maybe kind of making you, hey, let's just start doing them. You could see what you're struggling with because there were a lot of mistakes, but hopefully I think now is kind of starting to make sense, right? Everybody feeling a little better about it?
I got them all right.
What, Colin? Way to go. Way to go. All right. I wish I had a few more examples because I feel like we need it. Don't you feel like we need just a couple more? Yeah, I do too. I do too. All right. Oh, look at that. All right. There are 1, 2, 3, 4, 5, 6, 7 problems on this page. I want you to pick any 2 big numbers and any 2 small numbers and write them in scientific notation. Any big 2, what am I saying? 2 big numbers and 2 small numbers. And try them. Ready, set, go. Write them in scientific notation. That means your answer must have a times 10 in it. If you're doing a small number, make sure your exponent is negative. All right, we only have, what, 2 minutes? What? Okay, so let me just go ahead and do this while you're doing it. 2.36 times 10 to the second. Ah. Oh my gosh. All right, so this is what I'll do, guys. This is what I'll do. So we only have 2 minutes. I'm going to, when you get off, I'm going to type all of the answers to all of them, okay? Not only on this screen, but on the next screen also, because on the next screen, we're doing the opposite, okay? So those of you who just said, yeah, we need a few more examples, then I'm going to type the answers. I want you to come back to the slide deck. I want you to try them, and I want you to check the answers. Will you do that? Will you? Raise your right hand and say, I. Say your name. Promise, Miss Richardson. I will come back to her awesome slide deck and I will check my answers and she'll be so proud of me. God bless America. Okay, good job, good job. All right, don't lie to me. You just promised me you do it, so do it, okay? Hey, guys, I promise you, when we start adding, subtracting, multiplying, dividing with scientific notation, you're going to wish you had one of these calculators because it does everything for you. And if you don't have one, you have to do it all by hand, okay? You have 2 more days. We're going to do it on Wednesday. Have I yelled at you long enough? Okay. Everyone, have a great day. Good to see your faces. I'll see you on Wednesday, everybody.
I have a question. Can we take the scientific notion converting after the Zoom? We can if you want.
What? Can you do what?
Can we take the quiz for tomorrow today?
I think you should. Absolutely.
Okay, I was wondering because
Absolutely. Ashlyn's birthday is Thursday. I love it. Hey guys, everybody good? Y'all have any questions? Isaiah or Darius, I was going to check your answer, your grade, right? You good, Caleb? Oh, there he went. All right, Caleb, Darius. Oh, wait, hold on. I got to stop the recording. Give me a second, please. Let's see how do I stop the recording?